Our whole universe was in a hot, dense state. Then nearly 14 billion years ago, expansion started. Wait, yep. Although it says not like the TV show, the song of the TV show, The Big Bang Theory, is kind of correct. So let's get right into it. Let's take a look at this. About 14 billion years ago, expansion. Look at that. Expansion started. Wait. So what we have here is we are starting off with me moving my picture again because I'm on a lovely picture. You started off, not you, but in general, the universe is thought to start off from one tiny little thing called a singularity. And that tiny little thing, and when I mean tiny, I mean like a speck of dust tiny. So what happened was is that it began to expand rapidly. Expand, not explode, like we will see on the next slide. We are talking about expansion. So a lot of people, it's kind of confusing. I get it. It's called the Big Bang Theory. So what would you think? Explosion. Faux show. But it's not. It's more of a rapid expansion. So you can see here within the first seconds, this is part of the like the lighter elements forming, hydrogen and helium, those types of things. And then you can see you have more compounds, and then after 300,000 years, and after a billion years, and then after 14 billion years, that's where we are today. Excuse me. But what happened was during this expansion, there was a rapid release of energy as well. And just like when we release energy, we're also going to have heat that comes along with that. So not only did this expansion expand in all directions, it is like a firework in that sense, in that it went out in all directions, but not an explosion. But it did release a lot of energy with that expansion. And then with that release of energy, it caused the temperature to rise as well because of that massive amount of energy, just like the sun produces massive amounts of energy, also releases a lot of heat that comes along with that. So then, waiting for the computer. This all started very quickly. It all started in about a second. That expansion, that rapid expansion, and then it has slowed down over time. Incredibly sorry, my eye itches. Hot enough tonight. But about 15 billion years ago, you can see that you had this expansion. Then you're going to have about 10 billion years ago, the first stars are forming. About 5 billion years ago, there enters our sun, and then about 4.5 billion years ago, Earth, and then about 3.8 billion years ago, that's when our oceans first formed. So we are still expanding today. And we are going to show that support and other support for the Big Bang Theory with these three pieces of evidence. Let me go. I have to move myself probably multiple times on this. Maybe I can camp out there. Okay, so first of all, you have the red shift and the blue shift, but we are more so looking at the red shift. So we've talked about the electromagnetic spectrum and the wavelengths and things like that. So blue light has a shorter wavelength, as you can see in the picture here. When things move away from us and those wavelengths get longer, then objects are going to appear red to us, like it says here. So as something is farther away from us, the object is going to appear more red. And we have observed distant galaxies. They are getting off more of a red shift, which is telling us that it is expanding from an initial point, which supports the Big Bang Theory. Then you have what we call cosmic background radiation, kind of sounds funky. But this is thought to be the leftover radiation from that Big Bang, or when the universe first started to form. And then the elements that are present in the universe. So we have an abundance of hydrogen and helium in the universe, and those are two lighter elements. But the amount that we have of hydrogen and helium, and then the other elements that we have present in the universe, all support the Big Bang Theory. It gets way more complicated than that. So this is just a general overview. The Big Bang Theory is incredibly intense per se. It's kind of hard to believe that everything out there just started from one little piece of dust. But that is the theory, and here is the supporting evidence. So you and Sheldon Cooper are now in the know about the Big Bang Theory, and you can go answer some questions on it now. Good luck.